Hey, the next one from the homework in section 8.5 that I thought I'd look at, partial fraction decomposition. This was the original problem, and I went ahead and got the problem started, rewrote the integrand. I first factored out an x, and then this quadratic factored down to x minus 1 times x minus 1, which we should rewrite that as an x minus 1 quantity squared. So remember, we have to account for each distinct linear factor. So in the x squared minus 4 over x times x minus 1 quantity squared, we have to set up a partial fraction for this linear factor x. That gives us an a over x. And then this is a repeated factor. I mean, we can see it here. It's an x minus 1, x minus 1. But because it's the same factor repeated, remember we set up a b over x minus 1 plus a c over the x minus 1 quantity squared. So it's the same process. We multiply both sides by the LCD to get an x squared minus 4 equals a times x minus 1 quantity squared plus b times x minus 1 plus c times x. And as you know, we're going to pick strategic values for x. So, I'm going to start off picking x as 0. So if I pick x as 0, over here on the left I have a negative 4. This term's gone, that's term's gone. Negative 1 squared is 1. Oh, heck, we immediately get a. A is negative 4. That was friendly. The next strategic value that I would pick is x equals 1. So let's see, if I pick x as 1, that's gone, that's gone. Over here on the left, 1 squared minus 4 is negative 3. So we get negative 3 is equal to, oh, well, that's kind of cool. We immediately know c. Negative 3 is c. So the only thing you still have to figure out is the value for b. Well, once you know, well, there are no more strategic values to pick. You have to pick some other number, some other value for x. But look, once you know the values for a and c here, why don't we take these known values for a and c and toss them in here for a and c. So let's go ahead and toss these values in for a and c. That gives us x squared minus 4 equals, okay, a is negative 4, so let's put negative 4 here. So we have a negative 4 times x minus 1 quantity squared plus bx times x minus 1. Let's see, c is negative 3, so we put negative 3 in for c, so we get a minus 3x. Okay, now we're going to have to pick a value of x to toss in here. It doesn't matter. You pick any value of x you want. You just don't pick 0 or 1. And I would pick, I mean, this is just me, I would pick x equals 2. If I pick x equals 2, over here on the left I get 0. 2 minus 1 is 1, 1 squared is 1, so I have a negative 4 plus, see, there's 2, that's 1, so that gives me a 2b, and then minus 6. So negative 4 minus 6 is negative 10. Add the 10 over to the left-hand side, so you get 10 is equal to 2b, which tells us b is equal to 5. So now that we know the values for a, b, and c, we can toss them in here for a, b, and c, which means that original integral, the original integral, I'm going to try to squeeze that in up here. It means your original integral can be rewritten as the integral a over x, well, a is negative 4, so that's negative 4 over x, plus b over x minus 1, so b is 5, so 5 over x minus 1, And then c over x minus 1 quantity squared. C is negative 3. So minus 3 over x minus 1 quantity squared. And now you have a very straightforward integration problem to do. I mean, after all, the work is done in coming up with how to take this and break it down to here. The calculus is going to be the friendly stuff, because we immediately get negative 4 natural log absolute value of x plus 5 natural log absolute value of x minus 1 plus 3 over x minus 1 plus c. So that's all there is to it. If you're wondering, where I went from here to here, how did I do that? Well, you could work that integral off onto the side if you want. It's a basic, you either see what it is or you do a basic u sub. U would be x minus 1, and then you would be rewriting your exponent as u to the negative second, and that's what you should get. So that's all there was to this one.